let's talk about practical applications for energy efficient lighting. When I was asked to put together this presentation, I started doing a trip down memory lane and looking back at where we were, say, 10 years ago with LED technology and not being around. What really were the obstacles we were looking at in 2003? And I thought two really nice case studies to juxtapose against each other was CNBC's new global headquarters at the time versus NBC Sports, which just went live back in January. Back in 2003, I can clearly remember there being an inventory of 4K soft lights that we needed to power up. And rule of thumb back then was for every 6 20 amp circuits, you needed a 50 amp dimmer for just such 4Ks. I think we went out on the edge and we said, well, for every 10 20 amp circuits, we're going to use a 50 amp dimmer. And that was kind of stretching it. I was hoping we had enough 50s at the time. But very quickly we found that those 50s went away. The new technology between fluorescent and LED surpassed the even need for any of those 50 amp circuits. And at this point they're pretty much being used to 2 for 3 for 4 for and 5 for traditional tungsten fixtures. Flash forward to NBC Sports, we were starting to look at what type of power we might need in that environment. And I remember settling on 45 watts a square foot with CNBC, and we started to deliberate on what the proper amount of LED investment would be versus tungsten, and the folks at NBC decided to go with an 80-20 split. So 80% of the rig was going to be LED, 20% was going to be traditional tungsten. Driving some calculations around, we came around saying, okay, well, from an infrastructure standpoint, we feel 15 watts a square foot will cover us. Okay. Still a little bit of a leap of faith because it hadn't been done. We're talking about over 15,000 square feet of broadcast space across 5 studios with plans for future expansion of at least 3 more. So we went for it. One of the first considerations I ask everybody here to think about when you're talking about planning for the proper amount of light is to really look at intensity. A lot of people say, LDs love this, more light is better, give me more light. I could always work with that. Well, there's a dollar figure associated, thanks for coming, with that amount of light. So here in this simple example, we're looking at an ellipsoidal technology, 2 different manufacturers. The fixture on the right at 40 feet measures 153 foot candles. Most shooters today, with the cameras being high quality as they are, probably shooting around 45, 50, maybe 60 foot candles, that's about it. So immediately at a 40 foot height, most trim heights in a studio, even a large studio, doesn't really go past 21 feet high. So you're clearly going to be dimming this down at least 50, if not more, %. Fixture on the left is quite the opposite. It is 6 foot candles at 30 feet away. So again, in that 20 foot environment, it's clearly not enough punch there. But let's quickly look at a 10 foot high ceiling. What about a much smaller studio? Do you really need the oomph that this fixture's giving you? At 10 feet away, you're looking at 52 foot candles. There's nothing wrong with shooting at 52 foot candles with today's cameras. What's the fundamental difference between the 2 lights? $1,000 a fixture difference between example A and example B. Big budget impact for this very simple decision. If you need to buy a fixture, there is such thing as buying too much light and tying up all that capital in something that you may never need. So moving on. Here's an example of WABC, Channel 7 in New York City. Went live 2 years ago-ish. September 2011, okay. And John remembers it very well because he was the lighting designer on the project. And I use this particular example when we're talking about color temperature. Again, 10 years ago when you were trying to debate what type of color temperature you were going to shoot at, it was a pretty simple decision. You said, am I working with a street side studio? Do I have daylight streaming in? I got to go daylight. Or I need to use tungsten fixtures and I got to bump them up with some CTB. Pretty simple decision there. Once we start introducing all these LED fixtures, game changer. There's a simple element that now changes and revises that evaluation. And in this example, you'll see, again, 2 identical fixtures, both ellipsoidals. One is balanced for daylight and one is balanced for tungsten, utilizing LED technology. Clearly from this chart, you'll see at 15 feet away, you're getting 120 foot candles out of the daylight fixture, where you're only getting 102 foot candles out of its tungsten equivalent. What do we see here? Well, inherent to LEDs, they are more efficient at higher color temperatures. 5500K daylight is actually a more efficient source. Big caveat here, both fixtures are the exact same price. They don't cost you $1 extra to go with tungsten versus daylight. But you're getting more than 15% more light output out of your daylight fixture. Okay, now we're talking about it being more advantageous to shoot with daylight inside my controlled box. That's new, that's different. There are some great advantages to this. One of the caveats we would have said back in the day was, is there enough fixture selection at daylight? Well, all the fixture, hey Jeff, what's happening? All the fixture manufacturers that are dealing with developing LED fixtures are cranking out daylight version and tungsten versions with the same options. They're not limiting it just to tungsten. They're realizing that they're getting bigger bang for the buck out of the daylight, and you're getting a broad spectrum of fixtures to choose between. Soft lights, ellipsoidals, Fresnels are all available in both flavors. Another really big advantage, especially in a news environment or something like that, video displays. Everybody's putting behind their talent video monitors for any sort of stand-up position. What balance is better to the daylight monitors than daylight lighting on your talent? As long as the entire rig is properly balanced, either daylight or tungsten, the camera can white balance correctly and adjust for that. But you're getting better contrast lighting your talent in daylight with those screens behind. So that's another big advantage of going this way. All right, so next issue, color rendering index. Now we know that a rating of 100 is equal to tungsten light, full color spectrum. We like that. Tungsten looks great on camera. Well, now we're looking at all this LED technology, and we're hearing numbers like, well, for broadcast quality fixtures, I have to look for a rating of what's called 85 or better. So it's close enough to tungsten. 85 still looks good on camera. But what does that really mean? When we start looking at what tungsten is, we start looking at these simple sine wave charts here. Fixture on the right is a traditional RGB LED head. And it's being compared, juxtaposed to that tungsten sine wave curve. And you can see some really nice color out of those primaries. The red, the green, the blue actually exceed the color spectrum values of traditional tungsten. But in your secondary ranges, there's these huge valleys. Those valleys are what make things very difficult for LED fixtures to meet. Some of the manufacturers are trying to offset that. They start putting in supplemental chips. They get better technology. This is what you see when you start talking about 85 CRI or better. It's close. It's close enough. It's good enough for broadcast. You compare that and contrast that against the energy savings, and you go, yep, I'm going to go with it. It makes sense. It's not that big of a sacrifice to go there. Another thing to think about when you're pre-planning and discussing that new studio you want to install, first decision you can make, biggest bang for the buck, your cyc lights in your studio. Look, the red, the green, the blue, you take your 1,000-watt bulb, especially if it's a 3-banker and you've got red, green, and blue gel in there. You pop in a 200-watt LED red, green, blue head. That runs on 150 watts, if not less, and you get better contrast, just get more light output because you're not putting those big gels in front of the units. So the efficiency behind changing out your cyc lights is your first no-brainer in the entire equation. Got to change that. Got to turn those suckers off and go with your LEDs. It's when we start talking about white light and the fact that we have all these different options in white light where that decision becomes a little bit more complex because that capital expenditure is so great. Right out of the shoe, you got to spend 4 times what you would have spent on your tungsten fixtures. Let's keep talking about that. Where's the big money saver when it comes to infrastructure, pre-planning, and deciding to make that big capital expense? It's offset by your cooling system. Heating and cooling is where big money is saved. Now again, this works really well when we're pre-planning new construction or something that will actually impact the HVAC system. We're talking about a traditional studio like what we were doing at NBC Sports, planning on a 50-ton cooling unit for one of the rooms. We immediately were able to take that down to a 10-ton unit. Big money not only in the components, but think of the structural. This is in the roof. Now all the supplemental steel that has to go up there to hold all that cooling equipment has just plummeted. So I'm saving on structural steel all over the place. Some of the other considerations, and this is critical for broadcast. A lot of people may call up a commercial contractor, commercial engineer, and say, okay, let's plow through the pros and cons of what I need for my studio. But they're not a broadcast engineer. They're just someone from the community who's probably very well respected and really knows his engineering. But what he doesn't realize are all the little nuances that come behind our industry, the broadcast industry. We're talking about noise factor, right? Noise is such a big deal with that cooling system. Not only the compressors turning on in the middle of a live shoot, interrupting things, but also just the airflow. That little hum will drive those audio guys nuts. If it's not properly insulated, if the airflow is not low enough, critical point for HVAC in our industry, low flow, high volume. Low flow. The ducts have to be triple, quadruple the size they traditionally be in a commercial space, just to keep that noise level down. So there's already a big expense. There's already a big expense that we have to look at with our HVAC systems. Let's make sure we get the right one for broadcast. Another big deal, and this factors a lot with renovation. Let's say you make that decision, I don't have the money to touch my HVAC. I only put it in 5-6 years ago. It's working fine. But I'm going to make that leap to LED because I want to get the energy savings. Well, one of the things we talk about all the time is just turn it off. I don't need the HVAC. It's not hot anymore. My 1,000-watt cyc lights are off. My key lights that used to be 750 HPLs or 1K Fresnels are no longer on. So I just leave the unit off and my talent doesn't complain, so I'm fine with it. And over the course of a couple of months, in humid climates, that humidity starts building up in our studios, and mold starts to grow on our walls. Mold starts growing on our set. I just heard yesterday a case where there's mold actually growing in the HVAC system because it's not on enough. Remember, the climate control is also taking care of humidity. Big oversight. So now it's forcing you to evaluate that HVAC if you want to make the leap to something that's energy efficient. It's almost, our infrastructure is relying on that high heat factor. Last point when it comes to HVAC and cooling is that big misnomer with LEDs, really big, that LEDs don't generate heat. Heat's not an issue. They're not hot anymore. John just did a presentation not an hour ago where he's putting his hands on these fixtures going, look how cool they are. Could you have done this with another light? You couldn't, right? But it doesn't mean it's not generating heat. There's actually a tremendous amount of R&D being sunk into these fixtures by all the manufacturers to develop these really slick heat sinks to manage the heat that the LEDs are cranking out. And that's the key to the longevity of the LED. If you want to maintain that 50,000 hour rating you're getting from these manufacturers, you've got to keep them cool. You can't run them up in your ceiling grids at 90 and 100 degrees. It's not bothering your talent, it's not coming down, but the lights are baking. So you're doing serious damage to, again, a $2,000 fixture. You can't afford that, so you've got to maintain that climate up top. Let's break down a fixture really quickly. So what makes up a tungsten fixture? Again, it's basically a socket, it's a lamp, it's a reflector, and it's a Fresnel lens. Now we'll look at the exact same fixture made out of LED. It's this particular unit here. LED, what is it? It's made up of, again, same Fresnel lens, some sort of reflector. It's got an LED chip instead of a lamp, and it's got that heat sink we talked about instead of the socket. The one fundamental component we are adding to the equation that people don't think about is there's a switching power supply that goes in there. What's the byproduct of a switching power supply? Harmonics. Same thing that goes in your little computer. Now if you're sitting at home and you got one computer and you got one little transformer, a little power supply in your computer, big deal. Doesn't really have any impact on your home. But as soon as you start putting a couple of dozen of these lights, maybe a couple of hundred of these lights like NBC Sports did in your facility, you're starting to generate a tremendous amount of harmonics distortion. Let's take a look at that. Here's a traditional sine wave to the left. That's what your electrical line should look like in a scope. As soon as you start adding harmonic, you get what's called third harmonic, fifth harmonic, ninth harmonic, or some combination thereof. Those harmonics are creating resistance over your line. That's going back to your transformer in your building, and it's making your transformer work harder to offset all these harmonics. You don't see it, it doesn't affect you. Pretty much the only place us broadcast guys might see it is when the audio guys complain because there's buzz in the speakers, there's buzz in the audio mics. Maybe they're sharing the same transformer and they're seeing some of those harmonics that weren't there before the LEDs presented themselves. Same thing happens in our broadcast facilities with rack farms. We have these huge racks now containing all this hard drive space, all these computers, all these PCs. Those are creating the same harmonics. and it's wreaking havoc on our transformers. Building transformers traditionally by an engineer that, again, is not a broadcast engineer will say, oh, I've compensated for that. I've given you an Energy Star transformer. I've given you a K-rated transformer. Okay, that's nice, but all that means is I've beefed it up to compensate for those imperfections in the harmonics, and it's able to overcome what those harmonics are putting in. But the transformers are still working harder to offset those waveforms. That working harder is released in the form of heat. So I'm losing energy, I'm still paying my electric bill to offset these harmonics. So there's other devices that a broadcast quality engineer can help you with. There's basic zigzag technology, backwound transformers is another way of going, and there's also filtration systems that can help offset these harmonics. This is much easier to solve for renovation, because you can pay an engineer a small fee to come in and slap a meter on your system, let it record for 30 days, then he comes back with a report and says, here's how we offset all of your harmonics. I know exactly what you have. This many third, this many fifth, this many ninth. Here's how we're going to resolve it. It's much harder to do when you're trying to pre-plan a new facility and you're not exactly sure what the byproduct is going to be. So you got to put a broad spectrum transformer in, or something that's pretty much going to offset everything third, fifth, ninth. Again, a proper engineer that knows broadcast quality stuff is going to be able to advise you on how to do this. Questions? Comments? Piece of cake? Stuff you never thought of before, I bet, right? Well, that's what we're here for, so I hope this is helpful. Let's move on. So next issue is really big. Nobody realizes that every time we introduce one of these LED fixtures and we turn them off with our computer console and we leave at the end of the night, we bring that Grandmaster down and every light in the studio goes off, that every one of the electronics on board every one of these units are still running. The light's not outputting anything, but there's still electronics that are taking energy. That energy can come on the good side at about 5 watts a head. On the average side, we're talking 8 watts a fixture of energy consumption when you're dark. And how often throughout the day do we shoot? Maybe on a good day, 6 hours of actual broadcast time, actual tape time. So the whole rest of the day, at least 18 hours a day, we're burning 8 watts a fixture. Nobody talks about this stuff. It's not something, because again, we're pioneering new technology. These are all things we're learning together and we're developing together. Very simple solution for this is to include a relay panel on all of your circuits that are firing up your lights. So every one of the load circuits, before they go out to your pigtail, they go through a relay panel. And that relay panel can be, press one button, the whole relay panel turns off every circuit, and it disconnects the power from every one of your heads. Come in the next morning, press the same button, all the relays turn back on, and you've re-energized every fixture. Now you go over to your console, you bring up your Grandmaster, and you pick up right where you were the morning before. Simple, small investment. Any electrician could put this in. Best ones for our industry are one that take DMX control, the same protocol the fixtures are taking and the consoles are outputting, so the board operator could actually turn off the relays before he goes at home and not have to walk over to a supplemental button or forget to do it. And he could put it into his program where it automatically shuts him down as he goes home for the night. Questions? Did anybody know this or not know this before? This might be new news. I've heard a lot. New news, right? Yeah, it's just not something that's being considered. It's an easy fix, right? But if you don't put it in your budget, and if you don't pre-plan for it, you know, these panels, $1,500 a piece, maybe $2,000 for a 48 circuit panel. And then you're gonna need the electrician to wire it up. It'll probably take him a day to actually wire it up. So $3,500 investment, totally worth it. The payback on that is a couple of months when you think about 8 watts a fixture. Another big thing, data distribution completely changes as soon as we introduce LED technology. We now need a data cable to go to each and every head along with the power cable. We probably need a data cable out of each head to go to the next one in the line, right? So very fast we see these rat's nests of control wire up in our grid. So one of the quick solutions we see is wireless. Wireless has become very reliable for show-critical applications. It is not something that I'd consider you could buy from a DJ company or something that's lower grade. Professional broadcast quality stuff will do frequency band hopping automatically. It'll allow you to configure what part of the band you're going to use. It'll allow you to experiment, especially with other wireless that might be in your building. So you definitely want a system that'll allow you to configure it yourself and manipulate where it is. But once you get it set up, it's pretty rock solid. It'll hold in pretty well. The problem is it's not that economical to put a receiver at every single head. Just doesn't work well. You know, it's not practical. But you can put a series of them in your grid, and you can limit the amount of soft cable you're putting from head to head. So that'll take you a little of the way there. Something else to consider, and we've really been pushing the envelope on this. Biggest problem we've run into is in the new hang. You're putting in a new set, you're getting ready to hang and focus a new show. What happens every time? You get it all hung up, you get it all ready, you get it all programmed, and here comes your director. And he's going to come up with 6 new camera shots that weren't even thought of the night before. And the lighting guys are going to run all around to tweak everything. Or you walk in the first morning. Jim told a great story the other day, had all his paperwork done, had the crew showing up, had everything ready to go, and he walks in the first day, and the director goes, oh, we moved the set 6 feet to the right. I hope that's not a big deal for you lighting guys. It's like nothing, the paperwork, like you might as well crinkle it up and throw it out. You got to start all over again. So we're kind of used to that. That's old school. But as soon as we now no longer are dealing with one power pigtail, we're dealing with a data cable in and a data cable out. That's a tremendous amount of cable management we've got to do. So what you're going to see with this particular fixture, you're looking at the back of this particular light here for this example, but all of these fixtures have onboard capability for driving them and turning them on. So what I'm proposing as a process to hanging a new show is you come in and you do not install any data cable day one. You put in the power cable and you go to the back of the head and you press the bulb button and you turn it on at the head. Now you come, you lock in your focus, you tweak it, you frame it, you do whatever you need to do, you spot, you flood it, and you have your director come in and you say, let's block, let's do camera shots, let's get this locked down. I can turn lights on for you. I can't dim it necessarily, but I can turn them on and we can figure all this out. Then I'm going to leave my crew on late tonight. We're going to data cable the whole room, and we're going to cable dress and make it nice and pretty. Producers hate spending $100,000 on a brand new lighting system and the ceiling looks like crap. There's just cable everywhere. It's like, what did I spent all this money? Why does it look so bad? Well, you didn't realize that we moved lights 5 times and we shifted things to the left and we stole from here and put it over there and we had to do all these things. Well, can we clean it up a little bit? And like the crew's exhausted and they don't want to talk about cleaning cable anymore. So, simple fix right there. Another one of our favorites, and I'm a big advocate for this. Again, I was talking about CNBC at the beginning of this, and I was talking about that 80-20 rule, where 80% of the rig was LED and 20% was tungsten. Great way to go. Really good way to go. But you're still going to deal with some level of tungsten dimming. You're going to need to dim those tungsten fixtures. Especially on renovation work, you're probably dealing with centralized dimmer racks that already exist. You probably already own them. Some problems we should talk about very briefly when you're looking at that is you cannot run any one of these LED fixtures through that dimming system. Not only, a lot of people say, oh yeah, I'll just park them at full. I'll just leave them at full intensity. The SCR itself is doing damage to the chips on board these fixtures. You'd want to remove that SCR from the loop, get it out of the chain. So you've got to change those dimmer modules to relays potentially. Or you've got to do some sort of combination where you have dimmers dealing with the dimmed circuits and relays dealing with the other circuits. It's a cable management nightmare, especially if you get freelancers that come in to hang in new shows. They can't keep straight what's a dimmed circuit and what's a switch circuit. And they're constantly plugging. I see this at the college level all the time. College students just can't keep track of what's dimmed and what's switched. They plug it in, and these are no longer $400 or $500 lights. These are $2,000 lights. I do not want to break my new baby. And we're seeing that. We're trying to come up with, as an industry, a nice way to manage those switch legs from those dim legs. Another big disadvantage to these centralized racks, they come in pairs. So if every time you pull that dimmer module out, I'm losing 2 circuits, even though I probably only need 1. Damn, I lost 2 in that corner. That's where I needed it. So now I'm running extension cords back to that corner with switch legs instead of hot legs, instead of dim legs. So again, a lot to consider. Another really good fix, if we can pre-plan and if this is a new build, hybrid systems love portable dimmers. Bars that can go in the studios, dimmers that could go on the yokes or the sides clipped right on to the fixture heads. This way you can't make a mistake. The dimmer connects right to the tungsten fixture. Some negatives on that, the audio guys and the noise. You got to worry about those SCRs buzzing away. If you got a high enough ceiling, it may not be a problem, but you definitely want to consider the noise ramifications of that. The other thing is service and maintenance. No longer are you in a central closet down the hall where you can go pop out a module and put in another one. You got to get a guy up on a ladder. to go figure out why the dimmer's not working anymore. So again, we're pointing out here pros and cons to all of it, but we got to go with the flow. The new technology's here. It's not going away. It's our new staple item, and we've got to start coming up with solutions to solve some of these things. Questions about hybrid systems? Anyone? Cool. Last point. The fluorescent. Who said that fluorescent isn't energy efficient? Fluorescent hasn't gone away. It's almost as efficient as LEDs, right? The fundamental difference between that fluorescent and any one of these soft lights down here is about 30% less in your capital budget. That's a big number. That's a big savings. So when you start looking at soft lights, don't factor out fluorescent. Here we're again looking at WABC, which John designed. And this was, again, 2 years ago. Back in September of 2011, we didn't have all these options. We definitely didn't have all these Fresnels to look at. So John decided to go with key lights using LED Fresnels. He ended up going with fluorescent fill, which is exactly that unit. And he used this Airy broadcaster as a nice little backlight. Tucked up behind the set just beautifully. Didn't affect any of those wide shots. And it was plenty of intensity. Again, for a backlight or a hair light, it worked great. So it was a really good combination, but it was still green. It used fluorescent, but it was just as energy efficient. What are the only differences? Yes, you have to change the bulbs. Not a big deal when you can save 30% on a fixture. And I always like to end on a trend. This was the first day of air for NBC Sports with Costas tonight, and I noticed something as that first night was gone live and they had been blocking for about a week before. We all know that the directors love that jib shot. They love that sweeping, establishing shot. Anytime they can fit it in the room, they're going to use it. In this particular environment, they decided consciously to go with low-angle jib shots and showing that ceiling in their shots. It helps separate them from their competition. It was something they identified as a look that appealed to them. And because it was pre-planned, well in advance of us getting started, the scenic guys took full advantage of that and put in these ceiling elements. All these scenic pieces that you see here. All these tiles. To make that ceiling feel like part of the set. Make it feel like a room. Absolute nightmare for lighting guys. Working around all of these ceiling elements. But because it was properly pre-planned, because it was a critical element that the owner wanted to separate themselves from their competition, Bruce Ferry, Lighting Design and Associates, was able to do what I think one of the best executions of working around ceiling elements and making that ceiling disappear. You don't see cable messes, you don't see nightmares. They lit the panels beautifully. They worked around all the panels. They bounced light off of mirrors and reflectors and everything you could possibly imagine to pick up those key back and fill positions without interfering with or creating shadows on those ceiling elements from up above. Owner decision, it cost them money, it cost them time and crew, but it was made consciously. It wasn't made as an accident or, uh-oh, we forgot that this would cost us something. It was pre-planned to the max, and they pulled it off. So that pretty much wraps up a little 101 on things to consider when developing your new studio. I'd love to answer questions if anybody's got some.